Argentometri is a general method for determine the levels of halogenides and compounds others that form a precipitate with silver nitrate AgNO3 in certain conditions. Argentometri method, also called the deposition method, because argentometry requires formation relatively insoluble compounds or precipitates. Reactions underlying titration argentometry is AgNO3 plus Cl Ag S plus NO3 as an indicator. Potassium can be used chromate, which produces a red color in the presence of excess Ag ions. The argentometry method is even more extensive used is the back titration method. Silver nitrate AgNO3 is excessive added to the sample contains chloride ions or bromide ions. The remaining AgNO3 is then titrated again with ammonium thiocyanate using the indicator iron 3-ammonium sulfate. The reaction that occurs in determining chloride ions by titration return is as follows: excess AgNO3 plus Cl Ag S plus NO3. Remaining AgNO3 plus NH for SC and AgSca S plus NH for NO3. 3NH for SC and plus VNH for opening parenthesis, so for closing parenthesis to SC and 3 red plus 2NH for 2SO4. Before titrating again, alcohol should precipitate, filtered first or coated with additions. Diethyl phthalate to prevent dissociation of alcohol by thiocyanate ions. Halogens bound to aromatic rings cannot, liberated by hydrolysis, so it must be burned with oxygen flask to remove halogen before titration with the argentometry method. Titration curve for titrations involving precipitation following changes. Concentration, either analyte concentration or titrant concentration as a function of volume, titrant. For example, in the analysis of iodide ions I using Ag plus as a titrant, in the reaction, the titration curve can be applied between POG or placed as a function of volume, titrant. First of all, the titration curve must be calculated, and so on shows how quickly an understanding of the titration curve is carried out, which are made. Calculation of titration curve. For example, calculate the titration curve in titration 50.0 milliliters 0.050 mcl with 0.10 of Ag plus. Because the equilibrium constant fourth above reaction is large, then it is assumed that Ag plus and Cl react perfectly. First, calculate the volume of Ag plus required to reach the equivalence point. Reaction stoichiometry requires that. From the calculations above, it can be seen that 25.0 milliliters of Ag is needed for B reaches the equivalence point. Before the equivalence point is reached, Cl is in excess. We can calculate, for example, the concentration of unreacted Cl after addition of 10.0 milliliters Ag plus is if the titration curve follows the change in Ci concentration. Then PCI can be calculated as, if you want to follow changes in Ag plus concentration, then first, concentration must be calculated. To do this, values are used KSP axis. At the equivalence point, it is known that the concentrations of Ag and Ci are the same. Using the solubility product value at the equivalence point, then the values of POG and pi are the same, namely for 0.89 after the equivalence point. The titration mixture contains excess Ag. For example, the concentration of Ag plus after adding 35.0 milliliters titrant. Methods in argentometric titration. There are several methods in argentometric titration, namely method, Moore method. This method can be used to determine chloride and bromide levels in a neutral atmosphere with a standard solution of silver nitrate with addition of potassium chromate solution K to Cro4 as an indicate. At the start of the titration will silver chloride precipitates, and after reaches the equivalence point, then addition. A little silver nitrate will react with chromate by forming a silver precipitate. Chromate Ag to Cro, for which is red. Method Volhard. Method Volhard can be used to determine chloride, bromide, and iodide levels in an acidic atmosphere. If Moore's method is a direct titration of halogenide with a standard solution of silver nitrate, the Volhard method is a back titration.